Hello everyone, I am Dr. VRAO. I hope you are all fine and doing well. Before going to the lecture, my sincere request and suggestion to all of you is that please watch the entire video, because this video enables you to understand the concept of salt hydrolysis in nutshell and also problem solving. In the last videos, that is lecture 22, 23, 24, we had gone through the concept overview of salt hydrolysis and derivations, that is equations to calculate the pH of a salt solution upon hydrolysis. And moreover, from the last videos we came to know the definition of salt and salt hydrolysis. The definition of salt is: salt is a substance which does not release either H plus ions or OH minus ions in its first ionization is called salt. I repeat, salt is a substance which does not release either H plus ions or OH minus ions in its first ionization is called a salt. And we know the meaning of hydrolysis. Hydrolysis is nothing but adding water. That is, salt hydrolysis means that the meaning of salt hydrolysis is adding water to salt. What happens when we add water to salt? That results salt solution. When we concerns with the solutions, we need to address their pH and concentrations. Okay, so we have 4 types of salts, and we had discussed that 4 types of salts and derived the equation for pH, calculating the equations for calculating the pH of the resulting solutions. Okay, now we shall go for problem solving. Before we are going to solve some problems, let me allow to summarize the formulas. Okay, if you really like this video, extend your support by like, share, comment and subscribe. Okay, so before going to problem solving, let me allow to summarize the formulas. To solve the problems based on the salt hydrolysis, you all should remember 4 points. That is, point number 1. Point number 1. Salt derived from strong acid and strong base does not undergo hydrolysis. In fact, salt derived from strong acid and strong base undergoes hydrolysis, but the resulting solution is neutral in nature. That's why we use it to say that salt derived from strong acid and strong base does not undergo hydrolysis, because the resulting solution pH is 7. pH 7 means that the resulting solution is neutral in nature. Okay, so you remember the point, that is, salt derived from strong acid and strong base do not undergo hydrolysis. That is the point number 1. And the point number 2, salt derived from weak acid plus strong base. Salt derived from weak acid and strong base. The resulting, when we hydrolyze the salt derived from weak acid and strong base, the resulting solution is basic in nature. How can I say it? How can I say this? The resulting solution is basic in nature. Already I told you. In the combination of salt, whichever is strong, that strongness is ascribed to the resulting salt solution. Okay, here the base is strong base, so that basic nature is ascribed to the resulting salt solution. So, when we hydrolyze the salt derived from weak acid and strong base, the resulting solution is basic in nature. That is, pH of that solution is greater than 7. And the equation to calculate the pH is pH is equal to 7 plus 1 by 2 pKa plus 1 by 2 log C. That is the equation to calculate the pH. And one more thing is degree of hydrolysis, H is equal to root KH by C, and KH is equal to that is hydrolysis constant is equal to Kw by Ka. Then H is equal to root Kw by Ka into C. And one more important point is that is to be noted is that here from this equation H is inversely proportional to root C. That is on dilution degree of hydrolysis increases. That is, with decreasing the concentration means on dilution degree of hydrolysis increases. Okay. So, that is the second point. And the third point is salt derived from strong acid plus weak base. Salt derived from strong acid and weak base. Okay. So, when we hydrolyze the salt derived from strong acid and weak base, the resulting solution is acidic in nature. The resulting solution is acidic in nature, because here the acid is strong. This strongness is ascribed to the resulting solution. So, the resulting solution is acidic in nature. So, pH is less than 7. pH is less than 7, and the equation to calculate the pH is pH is equal to 7 minus 1 by 2 pKb minus 1 by 2 log C. And one more important as like in the case of weak acid and strong base, degree of hydrolysis is equal to root KH by C. But here the hydrolysis constant KH is equal to Kw by Kb. Okay, whichever is weak that goes to the denominator. Okay, so KH is equal to Kw by Kb, and therefore H is equal to root Kw by Kb into C. Okay, and here is also degree of hydrolysis inversely proportional to root C, that is on dilution degree of hydrolysis increases. So, that is the third point. And the fourth point is salt derived from weak acid plus weak base. Salt derived from weak acid and weak base. Okay, when we hydrolyze the salt derived from weak acid and weak base, the resulting solution, what is the nature of the resulting solution? Okay, so this is the special case. When we hydrolyze the salt derived from weak acid and weak base, the nature of the resulting solution depends on Ka and Kb, acid dissociation constant and base dissociation constant. Already I told you in the lecture 24, right? Okay, so and the pH for calculating the and the equation to calculate the pH of such resulting solution, that is the resulting solution from salt derived from weak acid and weak base, pH is equal to 7 plus 1 by 2 pKa minus 1 by 2 pKb. Okay, and one more important point in this hydrolysis of salt derived from weak acid and weak base is that degree of hydrolysis is equal to root Kh. Here we could not identify the relation between degree of hydrolysis and concentration term. Okay, so here the degree of hydrolysis is independent on concentration, right? And here the Kh is equal to Kw by Ka into Kb. And from this H is equal to root Kw by Ka into Kb. Okay, these are the 4 points or 4 equations that you should remember when you go for problem solving. Okay, now we shall go for problem solving. Problem 1 is calculate the pH of centimolar, that is m by 100 solution, that means a centimolar solution of sodium acetate at 25 degrees centigrade. Ka of acetic acid is 2 into 10 power minus 5, that is pK is equal to 4.7. Then find the degree of hydrolysis. You, before solving the problem, you should understand the problem and you should know what is that salt. This is the salt derived from weak acid and strong base, that is the salt derived from weak acid and strong base, CH3COONA. This is a salt derived from weak acid and strong base. So, what they asked to calculate the pH. We know the pH of salt derived from weak acid and strong base. Weak acid and strong base on hydrolysis that forms that resulting solution is basic in nature, that is pH is greater than 7. That pH is greater than 7. So, and the equation to calculate the pH is 7 plus 1 by 2 pKa plus 1 by 2 log C. 1 by 2 log C, because the pH is greater than 7, because the resulting solution is basic in nature. So, pH value is more than 7, that is why we need to add of pKa plus of log C. Okay. So 7 plus we have pKa value, that is 4.7 by 2, and we have the concentration of solution, that is m by 100, that is 10 power minus 2, that is log 10 power minus 2. Okay. So 7 plus this is 2.35 plus 10 power minus 2, that when minus 2 comes before the logarithm, that is minus 2 by 2 log 10. This is 1 and log 10 is 1. Therefore, 7 plus 2.35 minus 1. 7 plus 2.35, 9.35 minus 1, that is 8.35. So, pH is 8.35. Okay. But they asked to calculate the degree of hydrolysis. They asked to calculate the degree of hydrolysis. Degree of hydrolysis, we know the formula. Degree of hydrolysis H is equal to Kw by C. H is equal to Kw by C, and Kw is H is equal to Kh by C, and Kh is equal to Kw by Ka into C. Okay. And Kw is equal to, we know the value of Kw 1 into 10 power minus 14, and Ka value is 2 into 10 power minus 5, 2 into 10 power minus 5, and the concentration is 10 power minus 2. Okay, 10 power minus 2. So, this when 10 power minus 14, if you take this these two, 10 power minus 5 and 10 power minus 2 numerator, that is 10 power minus 7 by 2. Okay. So, 1 by 2. So, this is 10 power minus 7 by 2. 10 power minus 7 by 2. 10 power minus 7 by 2. Okay. 10 power minus 7 by 2. 1 minute. Okay. So, 10 power minus 7 by 2. 10 power minus 7 by 2, for the sake of my convenience, into 10 and by 10. If you take this 10 to numerator, that is equal to 10 power minus 8, 10 by 2, 10 by 2, that is 5, that is 5. So, when we, that is, we can write it as root 5 into 10 power minus 8. So, root 5 is equal to, I think 2.2 into, and we did it 10 power minus 4. Okay. So, 2.2 into 10 power minus 4 is the degree of hydrolysis. Okay. And the problem 2 is calculate the degree of hydrolysis. Calculate the degree of hydrolysis and pH of 0.1 molar sodium acetate solution. Kh, hydrolysis constant of sodium acetate, is 5.6 into 10 power minus 10. So, after reading the problem, I came to know that this is a sodium acetate. This is a salt derived from weak acid and strong base. Weak acid and strong base. Weak acid and strong base that undergoes cationic hydrolysis. That undergoes cationic hydrolysis, because sodium acetate, it is a salt derived from weak acid and strong base. Weak acid and strong base. But they asked to calculate the pH. But we have a equation to calculate the pH, that is pH is equal to 7 plus 1 by 2 pKa plus 1 by 2 log C. By using this equation, we are not able to calculate the pH because we do not have the data for pKa. Of course, we know the value of concentration, but we do not know the Ka value. So, in this case, we could not calculate the we cannot calculate the pH by using this formula. Okay. So, sodium acetate, it is a weak acid and strong base. Sodium acetate, it is a salt derived from weak acid and strong base. So, it undergoes anionic hydrolysis. It undergoes anionic hydrolysis, that is CH3 COO minus plus water interacts with the anion that forms CH3 COOH plus OH minus ions. That is why that solution is basic in nature. That solution is basic in nature. So, initial constant, but they gave that hydrolysis constant. Why I am writing this equation? How can I write this equation? Because they gave that hydrolysis constant. Hydrolysis constant, we can write the hydrolysis constant for a cationic hydrolysis or anionic hydrolysis. Here the sodium acetate undergoes anionic hydrolysis. So, we can write the hydrolysis constant for this. So, initially this ion concentration is C and these concentration, and before attaining the equilibrium these concentrations are 0, and after equilibrium, after attaining the equilibrium degree of hydrolysis, this ion interacts with water. So, that is called degree of hydrolysis, that is fraction of total salt that has undergone hydrolysis. So, here the CH amount under total concentration is C, and CH amount, that is hydrolysis fraction of total salt that has undergone hydrolysis into C, that gives the amount of concentration that has undergone hydrolysis. So, this much amount decreased from the initial concentration, and that much concentration is formed for acetic acid and OH minus ions. So, we can write the hydrolysis constant KH is equal to CH into CH by C into 1 minus H. We can write this as C into 1 minus H, C into 1 minus H. After cancelling the C, and if the H is less than 1, we know already, we know this H is less than 1, then we can write 1 minus H is equal to 1. So, we can write this as CH square. So, KH is equal to CH square, and H square is equal to KH by C, KH by C. So, we know the KH value and C value. From this we can find out the degree of hydrolysis. How can we find the degree of hydrolysis? H is equal to root KH by C. So, KH value already they gave that KH value, that is 5.6 into 10 power minus 10 by concentration is 0.1. When we solve this mathematical equation, we can get the H is equal to H value, which comes out to be 7.4 into we can solve that H square is equal to, we can remove the root, 5.6 into 10 power minus 10 by 0.1, that is 1 by 10 into 10, that is 56 into 10 power minus 10. So, H is equal to root of 56 into 10 power minus 10, that is 7.49. It is 7.4 into 10 power minus 5, 7.4 into 10 power minus 5. So, degree of hydrolysis is 7.4 into 10 power minus 5. So, due to time management, I can write the direct values in the calculations. You please calculate those equations. Okay, and this is the degree of hydrolysis, and what they ask to calculate, they ask to calculate the pH also. So we know the concentration of CH, concentration of OH minus is equal to, from this equilibrium you can write concentration of OH minus is equal to CH. So C, that means 0.1 into H is 7.4 into 10 power minus 5. This can be 1 by 10, 1 by 10, it can be written as 7.4 into 10 power minus 6, 7.4 into 10 power minus 6. Okay, so POH, concentration of OH minus is equal to 7.4 into 10 power minus 6. It is in the form of x into 10 power minus y. So we can write it as y minus log x, 6 minus log 7.4, 6 minus log 7.4 whose value is log 7.4 value calculate the POH. No need to calculate the POH because we can calculate the concentration of H plus ions, concentration of OH minus ions here. So we need to calculate the pH, then we need concentration of H plus ions. So concentration of H plus ions is equal to Kw by concentration of OH minus ions, because Kw is equal to concentration of H plus ions into concentration of OH minus ions. So concentration of H plus ions is equal to 10 power minus 14 by 7.4 into 10 power minus 6. We can write it as when we 10 power minus 14 into 10 power 6 by 7.4, this is 1 by 7.4 into 10 power minus 8, 10 power minus 8, 1 by 7.4 whose value is which comes out to be 1 by 7.4, 0.133, 0.133 into 10 power minus 8. This is the concentration of H plus ions. From this we can calculate the pH, we can calculate the pH. What is the pH? This is the pH is equal to, this is in the form of x into 10 power minus 5. So 8 minus log 0.133. So 0. Log 1.3, 0.133. We can write it as one minute. We can write this as concentration of H plus ions is equal to 0.133 into 10 power minus 8. Okay, we can write it as 1.33 into 10 power minus 9. It is in the form of x into 10 power minus y. Then pH is equal to 9 minus log 1.33. So log 1.33, that is 0.37. 1.33 is equal to 0.34 something. 9 minus 0.34. It is 8 log 1.33 is equal to, log 1.33 is equal to 0.13, 0.13, whose value is 0.13. 0.13 means 8.87, 8.87, 8.87. Okay, this is the pH. This is the pH of the equation. So pH is equal to 8.87. Okay, and the problem 3 is when 0.2 molar acetic acid is neutralized with 0.2 molar NaOH in 0.5 liter of water. The resulting solution is slightly alkaline. then calculate the pH of the resulting solution. Okay, here they ask to what they given that the resulting solution is slightly alkaline. The resulting solution is slightly alkaline, but what they ask to calculate? They ask to calculate the pH of the resulting solution. First of all, you should know what is that salt. What is that where from that salt is derived? That salt is derived from weak acid and strong base. That is salt derived from weak acid and strong base. Okay, so we can calculate the pH from this equation. That is, what is that? pH is equal to 7 plus 1 by 2 pKa plus 1 by 2 log C. Okay, okay, but they are neutralized అని చెప్పేసన్న. They are neutralized. Acetic acid is neutralized. Acetic acid is neutralized. Okay, so when the term neutralized is used, you should write the equation. That is, what is that equation? Acetic acid CH3COOH plus NaOH gives rise to CH3COONA. CH3COONA. Okay, so here the acetic acid is 0.2 millimoles before the equilibrium. Before the equilibrium, millimoles before the equilibrium. How can we calculate the millimoles or moles? Okay, they given that the volume is in liters, then we can calculate the moles. Moles, how can we calculate the moles? Molarity into volume in liters, 0.5. Okay, and NaOH, that is also a 0.2. Okay, and volume is 0.5. So millimoles before the equilibrium is 0. So millimoles 2 5 10. It is 0.1 and this is 0.1, and this much amount is formed at CH3COON. That concentration of sodium acetate is 0.1. So concentration of sodium acetate is 0.1 mole. Okay, and we know that degree of hydrolysis H is equal to root KH by C. Root KH by C. Root KH by C. And we know that KH for this salt is KW by Ka into C. Ka into C. Okay, Ka into C. And then we can calculate the Kw value is 10 power minus 14, and Ka value is they gave that Ka value 1.8 into 10 power minus 5, and the salt concentration is 0.1. Okay, so here we know the concentration. We should know the concentration term C, that is 0.1. That concentration can be obtained from the this equation, because they given that 0.2 molar acetic acid is neutralized with 0.2 molar NaOH. Then we need to what is it called? Then we need to write the reaction and calculate the moles or millimoles. From that we can get the concentration of the product. Okay, so 0.1. So 0.1, and this calculation which comes out to 10 power minus 14, this value which comes out to be 5.5 into 10 power minus 10. Okay, okay, this value comes out to be 7.14 to 10 power minus 5. 7.14 to 10 power minus 5. This is the degree of hydrolysis, and the resulting solution, what they given that resulting solution is slightly alkaline. So slightly alkaline means that is the concentration of OH minus ions is equal to We know the formula for concentration of OH minus ions, C into degree of hydrolysis. C, what is that? C 0.1 into degree of hydrolysis is 7.42 into 10 power minus 5. Okay, 10 power minus 5. We can 1 by 10, that is 7.42 into 10 power minus 6. So, concentration of OH minus ions is that, but they ask to calculate the pH. Okay, so we need a concentration of H plus ions to calculate the pH. So, concentration of H plus ions is equal to Kw by concentration of OH minus ions, because ionic from ionic product of water. So, ionic product of water. So, this is 10 power 14 and this is 7.14 to 10 power minus 6. This fraction which comes out to be 1.34 into 10 power minus 9. 1.34 into 10 power minus 9. So, concentration of H plus ions is this, and from this pH is equal to this is in the form of x into 10 power minus 5. So, 9 minus log 1.34. So, 9 minus 1.34, which log 1.34 is 0.33. It comes out to be 0.33. So, that is 8.77. 8.77. So, pH is 8.77. Okay, and the problem 4 is calculate the pH at equilibrium point when a solution of 0.1 molar acetic acid titrated with 0.1 molar NaOH. Okay, this is also a problem which is resemblance with the earlier problem, but in the earlier problem they gave that volume in liters, but they did not give the volume here. Okay, and the acetic acid is titrated with 0.1 molar NaOH. Okay, so when they gave that, when they gave neutralized or titrated with when they use those type of terms in the problem, we need to write the chemical equation and we need to calculate the concentration of products. Okay, so what is it called? Acetic acid is titrated with NaOH. What we get? We get sodium acetate CH3COONa. CH3COONa. Okay, so we need to calculate the millimoles or moles. Okay, moles. If you take the volume in liters, that is called moles. So, acetic acid concentration is 0.1 molar. They do not give the volume. So, we can take that volume is V, and sodium hydroxide concentration is 0.1 and they do not give the volume. So, V. So, before the attainment of equilibrium, the concentration of sodium acetate is 0. After establishing the equilibrium, moles after equilibrium, this is called 0.1, this is 0, this is 0, and this is out to be 0.1 into V, 0.1 into V. How can we get the concentration of sodium acetate? Actually, there is a term, there is a volume term. To replace the term, and the concentration of sodium acetate CH3COONa, concentration of acetate is millimoles that we obtained by total volume. Volume is V plus V, that is 2V. So, V are get cancelled, the concentration is 0.05. So, the concentration is 0.05. Okay. Now, when this is the salt from weak acid and strong base, and this resulting solution is basic in nature because the strong base is here. Okay, so concentration of OH minus ions, we have the formula for concentration of OH minus ions, C into H, C into H. So, where, and we know that C into H, H is root KH by C, root KH by C, root KH by C, and we know that C into KH is KW by KA into C. Okay, so we can write this formula. This C can be written as a root C into root C, and it can be written as root KW by root KA into root C. So root C get cancelled. Therefore, root KW into C by root KA. So that gives the value concentration of OH minus ions. Therefore, concentration of OH minus ions is equal to root KW into C by Ka. Okay. So root KW is 10 power minus 14 and C is 0.05 and Ka is they gave that 1.9 into 10 power minus 5, which this root which comes out to be 5.1 into 10 power minus 6, 5.1 into 10 power minus 6. Okay, so concentration of OH minus ions is this, and from this but they asked to calculate the pH. We need when we need to calculate the pH, then we require a concentration of H plus ions. So concentration of H plus ions is equal to Kw by concentration of OH minus ions. Concentration of OH minus ions. So 10 power minus 14 by 5.12 into 10 power minus 6. So concentration of H plus ions is equal to this fraction, which comes out to be there is another method for this. We can calculate the POH. From this we can calculate the POH, that is 6 minus log 5.12, log 5.12. So from this POH is equal to 6 minus log 5.12, log 5 value is 0.7 and 5 it is nearly approximately 0.7, that is which comes out to be 5.3. So POH is 5.3. From this we can calculate the pH. So pH is equal to 14 minus POH. So that is 14 minus 5.3, it is 9.3. Okay, 8.71, sorry, it comes out to be 8.71. So pH is 8.71. Okay, so we can calculate the concentration of H plus ions by dividing the Kw with the concentration of OH minus ions. Then also we can get the concentration of H plus ions. Of course, from POH also we can calculate the pH. Okay. Okay, and the problem 5 is pK of weak acid HA and pKb of weak base BOH are 3.2 and 3.4 respectively. The pH of their salt solution is. So by reading this problem, I came to know that this is a salt derived from the salt solution derived from weak acid and weak base. So we have a formula to calculate the pH of a salt solution derived from weak acid and weak base. The formula is pH is equal to 7 plus 1 by 2 pKa minus 1 by 2 pKb. Okay, so 7 plus pKa value, they given that pKa value is 3.2 and 3.4 respectively. pKa and pKb are 3.2 and 3.4 respectively. So 3.2 by 2 minus so this is 7, 1.6 minus 1.7. So this is 8.6 minus 1.7. Okay, So 8.6 minus 1.7, that gives 6.9, that is 6.9. So pH of this resulting solution is 6.9. So I hope you all understand this problems, and these problems enables you to do or to solve more complicated problems. Thank you. If you really like this video, then extend your support by like, share, comment and subscribe. Thank you. Thank you for watching.